Number 23. Two sides of a triangle measure 14 feet and 17 feet respectively. The included angle is 72 degrees. Approximately how long is the third side of the triangle? Draw it. Two sides of a triangle are 14 and 17 respectively. Respectively means in that order. So if I'm thinking about this one and this one, then it would be 14 and 17 in that order. So 14 feet, 17 feet. And the included angle is 72 degrees. So we're going to put a 72 degree angle right there. And then it says, how long is the third side, which we'll call X. You can call it whatever you want to. You know what? I'm not going to call it X. I'm going to call it B. We'll call it little b. Because when I'm looking for stuff in a triangle, and it's not a right triangle, it is very convenient to use the law of sines or the law of cosines. And those are based generally on triangles that are named A, B, and C. I just told you I was going to name this B, and I lied. Because if that's big B, that would be little b. My bad. That means this is little a. Okay. Now, the laws of sines and cosines are, like I said, they're generally used for triangles that are named A, B, C, but you can change the letters and do whatever you need to with them. The structure of it is pretty much essential. The structure pretty much remains intact is what I'm trying to say. Okay, we are looking for a little a, so if you look at your formulas, although you don't need to, here we go. Treat it like it's Pythagorean at first, almost. That comes first because that's what you're looking for. And then your other two come after that. That looks Pythagorean, not quite, but it's kind of. And then you always subtract, and it's always 2 of whatever those two are, so 2bc. And then this law of cosines, cosine of those. Those should match up with with lowercase and uppercase. Okay, let's pause here and talk about why we used the law of cosines instead of the law of sines. And here's the reason why. We knew a side, an angle, and a side. And anytime you have side, angle, side, that's going to be the law of cosines. And we can go through the big long list of when you do what with what. However, I think the best way to sum it up is this. Whenever you do not have an angle and a side that's across from it, then you need to use the law of cosines. If you don't have angle and side pair, angle and side pair, or angle and side pair, or can't easily find it by like subtracting from 180 or one of those things, then you need to use the law of cosines. So let's start filling some stuff in. We're obviously looking for a, so a squared equals little b, we've been through this, little c, minus 2, 14, 17. Fortunately for us, this is one of the easier ones. This is not one of the ones that you have to move things over one piece at a time because we're looking for a and it's already on that side almost by itself. Now, I want to point out something else too. Depending on what you've been doing with the other problems, there's a good chance you're in radians. Make sure you are in degrees. You need this to be in degrees. You may have to switch back and forth, so be careful. That is in degrees, be in degrees. So we grab our calculator, and we're going to type that in. My batteries are low. It recommends I change them. Not right now, I'm busy. Cosine of 72. Here we go. This is what I got. 945.41. That's great. It's fantastic. But we're not done. And we're not done because we need to square root. There we go. We'll square root both sides. And we'll get our answer. I'm not going to go any further on this. I'm going to say A equals, and then I'm just going to leave you hanging because you know how to finish this thing.